Hello everyone, my name is George Mugenyi. I welcome you to my YouTube channel, MG Maths and Science. Today we shall be covering some of the topics under pure mathematics, and we shall begin with algebra and subtopics. Under algebra we have surds, indices, logarithms, and many more. But before we continue, if you're new here, remember to turn on the notification bell and subscribe for more videos. Well, we shall begin with surds. And what is a surd? A surd is any irrational number that cannot be expressed as a fraction of other two integers. And this is what we mean. If we have a number like 4 can be expressed as 8 over 2. Now 4 is rational, and a number like root 2, which is approximately equal to 1.414 something. This is an irrational number. We cannot express root 2 as a fraction of two integers. Now this makes root 2 a surd, and this is what we call a surd, and this is a number, a normal number we are used to. Now surds are very useful. Like we said, in math we use surds in topics like trigonometry, we use surds in topics like coordinate geometry, and many more. Now for today we shall have to cover some of the computations used in surds, and we shall begin with simplifying surds. We shall continue with addition and subtraction. We shall later on continue with multiplication, division, and we shall finalize with rationalization. Now we shall, for today and for now, we shall begin with addition and subtraction of surds. Later on we shall continue with simplifying, multiplication, and the rest. But for addition we have some simple laws. Now if we have a surd given to us like root a plus root a, this gives us 2 root a. If we have the same thing as having p root a, now this is a multiple, then plus maybe q root a, this gives us, we can simplify this to give us p plus q root a. But we should take note, now where we see the addition sign, we can also replace this with a subtraction sign, simply by saying, maybe we can talk about it separately. Now this is for addition. Now for subtraction, if we have p root a, then minus q root a. Now take note that p and q or a can represent any number, 2, 3, 100, anything. Now this gives us, we can simplify this to give us p minus q, then root a. Now these are the simple laws we all know, and we should also take note that if we have p root a, then maybe plus or minus q root b, and these are not the same, these two. This is not equal to p plus or minus q root b or root a. Okay, so this doesn't hold. This is not true in mathematics. Maybe I can even try to erase it. So this is addition and subtraction. We are going to continue with multiplication, then later on look at simplifying surds. Okay, now multiplication, we have still a few simple rules we have to follow. This is multiplication and division. Now for multiplication, still I can try to list down the few rules we have to follow. Now if we have something like root a, s should stand for any integer, any positive integer, root a and maybe times root a. This should give us a. Okay, now this is where this comes from. Now root a times root a, this should give us, I'm trying to derive this to see where this comes from. This should give us root a times a. These are some of the simple rules we are following in surds. Now a times a from basic math, this is a squared. Now this squared should cancel out with this root. Okay, now to give us our a. Now this is where this a comes from. Now that is multiplication. Still, if we have division, for division we shall have root a divide by maybe root a. This should give us a 1 from basic mathematics. Yes, but still, if we have something like going back to multiplication, if we have something like p root a, then maybe times q root a, this gives us p times q, then times a. Remember this and this times this, these two give us a. Now this, when we multiply all this, it gives us pq a. Now these are the basic rules. Now maybe we can talk about simplifying surds using all this that we've talked about. Now simplifying, it's just combining the rules. I might think about some examples here. If we are told to simplify maybe a surd like root 63, okay, now 63 can be written as root of 9 times 7. Now we see that 7 is a perfect square number. Now I can simplify further to get, remember when we said root of a times root of a, or root of b even, I can even change this to give us b. This should give us root of ab. Now same thing here, root of 9 times 7, this is a multiplication. Root of ab, which is root of a times root of b. Now root of 9 times 7 should give us root of 9 times root of 7. I'm just trying to simplify. Now the root of 9 is a 3, then times root 7. Now root 7 is an irrational number, so I shall remain with root 3 root 7. Now this is simplifying. We can still talk about maybe if we are given a number like root of 63, maybe plus root of 28. Okay, we've said this is simply root of 9 times 7, then plus this plus root of, now 28 can be expressed as 4 times 7. Now we've said this gives us this, maybe I can go through it. This is root 9 times root 7. It's the same thing as this up, then plus then plus this root of 4, following the same rules for multiplication, times root of 7. Now this gave us this. I can maybe just write this here. Then plus, now the root of 4 is 2. Okay, then plus, this is a multiplication times root 7. Now this will finally give us 3 root of 7 plus 2 root of 7, where we can factor out root 7 to give us 3. Maybe I can put this up here to give us 3. Now I'm continuing this to give us 3 plus 2. I'm factoring out root 7. Okay, now this is the same thing as this, where if we have root 7 times 3, we get 3 root 7. Root 7 times 2, we get 2 root 7. So this gives us 5 root 7. Now this is the simplified version of root 63 plus root 28. This is what we mean by simplifying surds. We shall later on look at more examples, but for now I can continue to our next subtopic. Now we can look at rationalization. Still, this is another simple subtopic, but please, before we continue with rationalization, if you've not yet subscribed, hit the subscribe button and turn on the notification bell. Now rationalization simply means it's more simplifying, but in math, if we have a number like a half, this is okay, but writing 1 over root 2 is improper in math. If this can be further simplified, we can simplify it. We can do so, simplify it, and we use a process called rationalization. Now this is what we are going to talk about. Now rationalization, we have two forms. Now there are two forms. We have simple and compound. If we have under simple, we can talk about some fractions like 1 over root 2, and here we use a simple tactic of rationalizing this just by multiplying this up here and down. Here we have root 2 times root 2, then 1 times root 2. Here I've not changed anything because this can cancel out with this. This root 2 can cancel out with this. So I'm still having the same thing, as in this is the same as 1 over root 2. Now here, if I get this times this gives me root 2 over. Now we should remember the rules. I'm multiplying root 2 times root 2. If we can remember root a times root a, this gave us a. Now this should give us 2. Okay, now this is the simplified way of writing our fraction, which is 1 over root 2. Now this is a simple way of rationalizing. Still, we can look at more examples. Maybe can talk about a number like maybe 3 over root 5. Now if you're told to rationalize this or simplify this further, you can simply say this is 3 over root 5 then times root 5 up and down times root 5. Here I've not changed anything, that's why I'm putting the equal signs. Now this should give me 3 times root 5. This gives me 3 root 5, and this should give me 5 from the rules we talked about in multiplication. Now this is a simplified version of this. Now let's continue with compound rationalization. If we have the previously we've just talked about 1 over root 2, but we can talk about numbers like 1 over maybe root 2 plus 1. If we have a number like this, what's the approach? What's the way to go? Here it's a simple trick, just changing the sign given to us and multiply the new compound denominator up and down as we did before. Now here I'm just going to change the sign. I shall say this is 1 over root 2 plus 1, then this is equal to 1 over root 2 plus 1. I'm going to multiply the same thing up and down. Here I will multiply, I just change the sign here, then multiply the same thing up and down. This is what we call a conjugate of this, root 2 minus 1. Now I'm multiplying this times this times this. Now this should give me root 2 minus 1 over, now this is multiplication. From our basic multiplication, I can continue this by saying root 2 times root 2, which gives me a 2. Now root 2 times negative 1, this will give me negative root 2. Now 1 times root 2, this should give me a plus root 2. Now 1 times negative 1, this gives me a negative 1. This is the same thing as root 2 minus 1 over, simplifying this 2 and this 1, we shall have 1, a positive 1. Now this and this, they cancel out, and we shall have negative root 2, and then plus root 2, which gives me a plus 0. So this is simply root 2 minus 1. Or from this step we shall look at another method of simplifying this without going through this hardship, but for now we can continue with this. This is simply that. Well, remember when we said surds can be used in trigonometry, we can try to involve in some trigonometry. Still under compound, I can have a number given to us like maybe 1 over 2 plus cos, this is a 2 cos 45 degrees, and you're told to simplify. To simplify 1 over 2 plus cos 45. Now we all know cos 45 as a ratio is written as 1 over root 2. Okay, now I'm going to introduce my cos 45 and replace it with 1 over root 2. Okay, this is 1 over root 2. This is now 1 over 2 plus 1 over root 2, and which we can further simplify because this alone can give us, if I bring this here, 2 plus 1 over root 2, I shall have, this is out of 1, this gives me root 2 root 2 times this, that is 2 root 2 plus 1. This is what I get after simplifying this whole thing here. So I'm going to replace this and say 1 over this 2 root 2 plus 1 over root 2. Okay. Now this root 2 can go up here and I get root 2 over 2 root 2 plus 1, which I can further simplify. Remember when we talked about getting the conjugate of this by just changing the sign here, putting a negative, multiply this same thing with a negative instead of a positive, up and down. It's what I'm going to do. Don't need this. So I have root 2 over 2 root 2 then plus 1. This is the same thing as I'm going to change the sign here, multiply the same thing up and down. So I shall have root 2 over 2 root 2 plus 1, okay, then times 2 root 2 minus 1, just changing the sign here, then still here times 2 root 2 minus 1. Okay, now this will give me, these are equal signs, sorry, now this should give me root 2 times 2 root 2. Remember root 2 is root 2 times, I have 2 root 2 times 2 root 2. Now this is the same thing as root 2. Okay, 2 times root 2 times root 2, and this is 2. Root 2 times root 2 is a 2 times a 2, which gives me a 4. Okay, that is a 4. Now up here I have a 4. Now root 2 times negative 1, that is a negative root 2, and a 2, this is a negative root 2. Then this down here, 2, I have, this is what we have, 2, I'm multiplying this times this, 2 root 2 times 2 root 2, this 2 times a 2, that gives me a 4, and root 2 times root 2, that gives me a 2, which finally gives me an 8. Okay, so I have 8, that gave me 8. Now this root 2 times negative 1, that gives me negative 2 root 2, then 1 times this 1 times 2 root 2, that gives me plus 2 root 2. Okay, now 1 times negative 1, that gives me a negative 1. Okay, now this is what we have. I can continue simplifying this. Now this is a negative, this is a positive, 2 root 2. You're not allowed to cross, but for now, for better explanation, you will allow me to cross these two, showing you that this negative has cancelled out with this positive root 2, 2 root 2. Now 4 minus 1, that is 7. Now we have a 4 minus 7 root 2. This we can continue by saying 4 over 7 minus root 2 over 7. That is our final answer. Okay, yeah, so this is finally our solution for the question we had. Now for now, this is what we call rationalization. Maybe on rationalization I can leave us with a simple exercise that you guys shall give me as feedback in the comment section. You shall share your solutions. So maybe we can have 2 root 2 minus root 3, then root 2 plus root 3. So I want you guys to try out this. Tell me your solutions in this comment section, and please remember to subscribe, hit the notification button. Yeah, till we meet again. Thank you for listening.